Hello everyone, you are welcome to another segment of our class. We are going to be continuing from where we stopped regarding our chemistry lesson. So we are still on acid, bases and salt. So today we are going to continue from where we stopped under our lesson. So calculations of pH. So we want to see how to calculate the pH of a particular solution. Okay, so calculating pH of solution. So if you could remember, we said pH in our last class refers to the concentration of hydrogen protons present in solution, which we are going to be taking a look at the formulas which we are going to be using in calculation of the pH. So if you have the chemistry note, you open to the page we are in, that is lesson 12, page 10. So we said the following or any, when necessary, can be used to calculate the pH of a solution. So these are the formula which we are going to use in calculating the pH. The first one, we have pH, we have minus log the concentration of hydrogen, or you can use pH equals to log 1 over the concentration of hydrozonium ion or oxonium ion. You can use this particular formula for that. You can as well use another one which says pH is equals to minus log the concentration of hydrogen proton, or you can use pH is equals to log the concentration of 1 over this, or you can as well use this which states that concentration of hydrozonium ion is equals to times concentration of hydroxide ion is equals to 1.0 times 10 raised to the power of minus 14. So this important formula, anyone can be used in calculating the pH of a particular solution. So I have some examples here with us which we are going to be taking a look at one by one. So let's take a look at examples. Number one, we have calculate the pH of pure water at 25 degrees Celsius if the hydrozonium concentration is 1.0 times 10 raised to the power of minus 7 moles per dm cube. Okay, so that is one. Then two, we have what is pH of a solution, this is the pH of a solution containing number 1, we have 0.01 moles per dm cube of solution. Roman 2, we have 0.01 molar. This one is for hydrochloric acid, and then this one is for sulphuric acid. Okay, that is question 2. Then example 3, it says calculate the pH. Calculate the pH of a solution, okay, containing 0.001 moles per dm cube of sodium hydroxide. So these are the examples that we are going to be taking. Then let's add more. At least let's add like 5. We said a solution has a pH of 4. What is the concentration of hydrozonium ion present? Okay, then question 5, we have an orange juice. An orange juice, we said, has a pH of 3.80. So what is the concentration of hydrozonium ion and OH ion in the juice? Okay, so then the last question here is question 6. We said the hydrogen ion concentration of a 0.5 moles per dm cube solution of ethanoic acid is 1.80 times 10 raised to the power of minus 5 moles per dm cube. So what percent of the acid, what percent of the acid is ionized? What percent of the acid is ionized in the aqueous solution? The aqueous solution. So that is that. So these are the questions we have, which we are going to be taking a look at the solutions one by one, how we are going to solve the problems using any one of these formulas. So it is very, very important you catch up with us in another episode of the class to see how far we are going to solve the problems one by one, so as the case may be. So should in case you are taking a look at the solutions there in your note, it is strongly advisable to pay attention to the steps we are going to be using to solve. So some steps may not appear to be the same as the one present in your note. So, but by the time you try as much as possible to look at the video, watch the steps I'm going to be using to solve, that will give you a better understanding. So thank you very much until I come your way with the solutions in our next class. Thank you. Hi everyone, you're welcome to another segment of our class. So where we are going to continue with the second section of the class we begin. So I'm here to give us the solution of the questions we already have. So I will read the questions once again. The first question says, calculate the pH of pure water at 25 degrees Celsius if the hydrozonium concentration is 1.0 times 10 to the power of minus 7 moles per dm². So we start by writing solution here. So if you are with your calculator, this is where I have mine here, you can bring it out so that we teach you how to punch and provide some answers. So number one, we say that okay, we bring out the parameters. We don't need this 25 degrees Celsius because it is the pH temperature, so it has no application when it comes to making use of the formula. Then we already have the concentration of the hydrozonium ion present in water. Hydrozonium ion has its own contents being present in water, and the concentration is given to us here, which is 1.0 times 10 to the power of minus 7 moles per dm². So we make use of the formula which states that pH is equals to minus log the concentration of hydrozonium ion. Now, since the concentration of the hydrozonium ion is given to us, we just go ahead and substitute in here, which is equals to minus log times 1.0 times 10 to the power of minus 7. So when we expand the bracket, this is now going to be, we have minus log of 1.0, okay, plus minus log of 10 raised to the power of minus 7. So when we punch minus log of 1, we're going to have 0, okay, plus then we have minus log of 10 raised to the power of minus 7 will give us 7. You can see that. So all in all, 0 plus 7 will give us what? 7. So therefore our pH of the pure water is 7, which means that it is neutral. Is that okay? It has no effects on litmus paper, so it is neutral. Then that takes us to solution number 2. Question 2 says, what is the pH of a solution containing Roma 1, 0.01 molar concentration of hydrochloric acid and 0.01 molar concentration of sulphuric acid? Now, these acids, as the case may be here, what is responsible for their concentration is the presence of the hydrogen proton that is present there. So, in this case, we are going to first of all write the ionization. So, you have hydrochloric acid. When hydrochloric acid ionizes, it gives us hydrogen proton plus what? Chloride ion. So the concentration here is already given to us in the question. And we have 1 mole here. So this is going to be 1 times 0.01. So which is 0.01 moles per dm³. So the pH is now going to be equals to minus log the concentration of what we have here, which is 0.01. Okay, so this is now going to be minus log of 10 raised to the power of minus 2 when you carry out the calculation process. So this is equivalent to saying we have minus 2 times minus log of 10 to base 10. So this is going to be minus minus will give you plus if you are multiplying. So you have 2 log 10 to base 10. So and log 10 to base 10 is 1. So this is the same thing as saying 2 times 1 and then which is equals to 2. So therefore the pH of this very particular hydrochloric acid solution is nothing other than 2. So I hope this is clear. So let us move to the second one, which is for sulphuric acid. We have the ionization here as this is Roman 1. This one will be Roman 2. So we have sulphuric acid here. When sulphuric acid ionized, we have 2 hydrogen proton plus what? Plus a sulfate ion. These are the 2 ions that will be produced when sulphuric acid gets ionized in the process. Now in this case, it is very, very important for us to take into proper cognizance that the concentration, which is the number of moles of hydrogen ion there, is equals to what? Equals to 2. So in this case, we are going to multiply the concentration here. So this is going to be 2 times the concentration we have, which is 0.01. In that case, this will give us what we have as 0.02 moles per dm cube. So this is the concentration of the hydrogen proton present in the acid, as the case may be. So we can go ahead now and calculate the pH of the acid solution. So pH is now going to be equals to minus log the concentration of the hydrogen proton that is present in the acid solution, which is equals to minus log of 0.02, which is minus log of 10 raised to the power of minus 2, which is equals to, if you look at it, we have minus 2 plus or minus log, okay, of what? 10 raised to the power of 1. So this is the same thing as saying the concentration is what? Is 2 also. Now this is the pH of sulphuric acid and hydrochloric acid solution. If you take a look at it, the concentration here as it is, we already have okay, this is okay. From here we have 0.02. Now this 0.02 is the same thing as saying 2 times 10 raised to the power of minus 2, sorry, 2 times 10 raised to the power of minus 2, which will give us this. So this one is times 2. Okay, so this is going to be, from this point we have minus log, okay, of 2 plus we have minus log of 10 raised to the power of minus 2. So in this case, minus log of 2, what we are going to have is, okay, we have minus 0.30, okay, then we have plus log of 2, 10 raised to the power of minus 2, okay, so what do we have there? Okay, we have minus log of 10 raised to the power of minus 2. So we have 2 here. So minus 0.30 0.30 plus 2 will give us, we have 2.3 moles per dm cube. So this is the pH of hydrochloric acid solution. So take note of that. So in this case, we move to solving the other questions without wasting much of our time. So question 3 says that calculate the pH of a solution containing 0.001 molar of sodium hydroxide. So how do we solve this very particular question? Very simple. Now sodium hydroxide, we form this ion. We have sodium ion plus OH minus. So in this case, what do we have next? We take a look at this very particular equation and say that, okay, here we have OH and we've been given the concentration of sodium hydroxide here, which if you observe, 1 mole of sodium hydroxide gives us 1 mole of hydrozonium ion here. So how do we calculate the pH now? So since we have 1:1, we can say that, okay, the concentration of the hydroxide ion present is equals to 0.001 moles per dm cube. That is the concentration of the hydroxide present in the sodium hydroxide. Since it is the hydroxide that is responsible for the basic nature of sodium hydroxide, and it is 1 mole of the sodium hydroxide that produces 1 mole of the hydroxide ion. So we say that the concentration of the hydroxide ion present in sodium hydroxide is 0.01 moles per dm cube. So we make use of the formula which states that concentration of hydrozonium ion, okay, times concentration of this is hydrozonium ion and this is hydroxide ion is equals to 1.0 times 10 raised to the power of minus 14. So we already have this. So we are going to calculate for the concentration of So as I was saying, we said that, okay, we are going to make use of the concentration of the hydrozonium ion towards calculating the pH of our solution. So we are going to make use of what we have here. Is that understood? So in this case, we said that, okay, the concentration of hydrozonium ion here times whatever we have here, which is 0.0, or we have 0.001, okay? It's now equals to 1.0 times 10 raised to the power of minus 14. Now in this case, we now say that, okay, to make this subject of formula, we have to divide this side. So we say that it implies that the concentration of hydrozonium ion here is equals to 1.0 times 10 raised to the power of minus 14 divided by 1.0 times 10 raised to the power of what? Minus 3. Okay? 10 raised to the power of minus 3 as we have here. So in this case, we can now go ahead and say that, okay, from these very points, we have cleaned this very one. The solution has a pH of 4. So it says that calculates the hydroxonium ion concentration. Now, from here we say that, okay, hydroxonium ion concentration here is equals to, we have 1 times 10 raised to the power of, we have minus 14 plus 3. So minus 14 plus 3, we are going to have minus 11. So we now use this, we say that, okay, pH is now equals to minus log the concentration of hydroxonium ion concentration, which is equals to minus log of 1 times 10 raised to the power of minus 11. So we have minus log of 10 raised to the power of minus 11 is going to give us 11 here. So that is the pH of the 0.01 molar concentration of sodium hydroxide. So that is that. Then question 4 says that a solution has a pH of 4. Calculate the concentration of hydroxonium ion concentration. Are we together? So in that case, we are going to do that by taking care of this side. I believe you are with me, we are following, we are moving. So what do? We already have pH given. This is solution 4. We already have pH given, and the pH is already 4. So using pH is equals to minus log the concentration of hydroxonium ion present. pH here is equals to 4, which is equals to minus log the concentration of hydroxonium ion. So we multiply both sides by minus 1 so that we can easily remove the negative sign and make it easier for us to find the antilogarithm here. So multiply both sides by minus, and this becomes minus 4 is equals to log of hydroxonium ion concentration. So which means implying that we have the concentration of hydroxonium ion is now equals to minus 4 times 1 all over log. And 1 all over log here simply refers to anti-logarithm, okay? So in this case, this is now equals to anti-log, okay, of minus 4, which is equals to what? So to take the anti-log of a number using your calculator, if you are using Casio, this very particular model, so just press to second function, then press on log, okay? You will see the display there. Then you now take off minus 4. Is that understood? So which will give you 1.0 times 10 raised to the power of minus 4 moles per dm³. So this is the pH, or sorry, this is the concentration of the hydroxonium ion present in the solution. As easy as that. Then question 5, an orange juice has a pH of 3.8. What is the hydroxonium ion and hydroxide ion in the juice? Wow, this is an important question which we are going to solve and look at it together, which I expect you to understand. At the end of this lesson, I have quiz for you to solve, of which you can post your answer in the comments box so that I can see what you already have as as the case may be here. Alright, now let us take a look at the solution to question number 5. So, the pH of the orange juice is already given to us. So, which is, we say pH is equals to, we have 3.8. That is our pH. Now, we don't know the concentration of oxonium ion and hydroxide ion, which is what we are going to look for. So you have to sit down, relax, calm down, and know which formula you are going to use. So remember the formula we are going to use? So we now say, okay, using the concentration of oxonium ion times the concentration of OH minus is equals to 10 raised to the power of minus 14. Is an important formula to use here. Now, in this case, we already have our pH, okay? So what do we do now? But there's a problem. We can't just use this until we know what one of this is. And for us to know what one of this is, we have to know the concentration here. So we say pH is equals to minus log the concentration of hydroxonium ion. So pH given is 3.8, which is equals to minus log concentration of hydroxonium ion. Is that okay? So which implies that concentration of hydroxonium ion in the orange juice is going to be minus 3.8, okay, times 1 over log. So this implies that concentration of hydroxonium ion in the orange juice is going to be equals to antilog, okay, of what? Of minus 3.8. So, as I said, press your second function, press on logarithm of minus 3.8 directly. Make sure you put the minus 3.8 in bracket, the way it appears here. So you get 1.5 times, okay, 1.58 times 10 raised to the power of minus 4 moles per dm³. So that is what we have. After you must have done that, you now substitute in the value of the concentration of the oxonium ion you have into this very particular formula, which you can calculate for the other part of the question. Remember, you've already calculated the other part of the question, which is calculating the concentration of the oxonium ion present in the orange juice. Are we together? Now, the next thing you are going to do is substitute it there. So, in that case, we have 1.58 times 10 raised to the power of minus 4, okay, times the concentration of the hydroxide ion that we are calculating for, equating it to 10 raised to the power of minus 14. If we do that, it implies that we have concentration of our hydroxide ion is now going to be equals to 10 raised to the power of minus 14 divided by 1.58 times 10 raised to the power of what? Minus 4. So this is going to be equals to, okay, 10 raised to the power of minus 14 divided by 1.58, okay, times 10 raised to the power of minus 4. That gives us 6.33 times 10 raised to the power of what? Minus 11 moles per dm³. So these are the concentrations of the hydroxide or oxonium ion and the hydroxide ion present in the orange juice. Then, lastly, which is question 6, it says that the hydrogen ion concentration of a 0.5 moles per dm³ solution of ethanoic acid is 1.80 times 10 raised to the power of minus 5 moles per dm³. So what percent of the acid is ionized in the aqueous solution? Now, for us to do that, we need to remember that calculating the percentage ionization of this type of acid is going to be very, very interesting. Now, we use this formula. We state that percentage of acid ionization, okay, percentage of acid ionization is equals to the hydrogen ion concentration present in solution divided by the concentration of the acid. Is that okay? Now, this is the formula, chemical formula of the acid given to us. Now, times 100 over 1. Is that okay? Now, which is now equals to the concentration of the hydrogen ion is already given as 1.80 times 10 raised to the power of what? Minus 5 divided by the concentration of the acid solution is 0.5. Okay, we have 0.5 times 100 over 1. Is that understood? So to finally calculate this, we now say that okay, we 1.8 percentage of acid ionization, percentage of acid ionization is now equals to 1.8, okay, times 10 raised to the power of minus 5 divided by 0.5. Okay, so we have 3.6 times 10 raised to the power of minus 5 times 100 over 1. So what are we going to have? We now say that okay, times 100. Okay, so we have 3.6 times 10 raised to the power of minus what? Minus 3 percent. So if you want to convert it to decimal, not standard, you have 0.0036 percent. So you can see it is not even up to 1%. So, dear students, I believe we have come to the end of solving the examples, which I am very sure you find this interesting and very simple. So I urge you to study carefully and you will be able to come across some questions like this, either in your CA or exam. So for those that don't have the notes, I'm going to give you a quiz which you should solve when you are at your convenient space of time. Now, question 1, you can take down this question. A sample of fruit juice has a pH of 4.2. What is the concentration in molar of hydroxide ion in the juice? I repeat, a sample of fruit juice has a pH of 4.2. What is the concentration in molar of the hydroxide ion in the juice? That is question 1. Question 2, the concentration of hydroxonium ion in 2.5 molar solution of benzoic acid is 8.02 times 10 raised to the power of minus 3. Calculate its percentage of ionization. I repeat the question. The concentration of hydroxonium ion in 2.5 molar solution of benzoic acid is 8.02 times 10 raised to the power of minus 3. Calculate its percentage of ionization. So, this is what we can have as far as this package is concerned. So when next we come to your way, we are going to continue from importance of pH values. Why are pH values important as far as chemistry is concerned? So we are going to be looking at this in the next episode of our class. So thank you very much and remain blessed. Don't forget to subscribe to Jetstream Tutorials. With Jetstream Tutorials, you can go an extra mile towards preparing for whatever type of exams that you may be sitting for. So just make sure you subscribe and invite others to subscribe too for more important videos. So we have packages, we have mathematics, we have biology, we have physics, and here we have chemistry. There is also English language, so which Jetstream will be giving you packages on this. So thank you very much, remain blessed. Bye bye.